How could a cube of a mouse brain no bigger than a grain of sand teach machines intelligence and help model artificial intelligence to human brains? Up till now, artificial intelligence has only been loosely modeled on the brain. So, what if you wanted to change that and perfect it to mimic the human brain? You'd need to do what has been impossible until now. You'd need to map what actually happens in neurons and nerve fibers. This is when the impossible becomes possible. Not only that, but now it has become a reality. Neuroscientists have just released the most detailed 3D map of the mammalian brain ever made, created from an animal whose brain architecture is very similar to our own. The mouse. The map and underlying data set depict more than 200,000 neurons and 500 million neural connections contained inside a cube of mouse brain no bigger than a grain of sand. I've left you the link to this data in the description below to see the map for yourselves. It's absolutely amazing. You'd have to watch it to believe it. The new research is part of the Machine Intelligence from Cortical Networks program, which hopes to improve the next generation of machine learning algorithms by reverse engineering the cerebral cortex. This is the part of the brain that in mammals is responsible for higher functions like planning and reasoning. A consortium of researchers led by groups from the Allen Institute, Baylor College of Medicine, and Princeton University, collected the data. Some people think that maybe the fundamental secrets of human intelligence are to be found in studying the cortex, says H. Sebastian Sung, a professor of computer science and neuroscience at Princeton. That's why it's been such a mysterious, glamorous subject in neuroscience. As scientists learn more about the brain, their discoveries could lead to more human-like AI. Creating the map was a 5-year project with 3 stages. The first involved taking measurements of what the mouse's brain did when the animal was alive. This produced more than 70,000 images of active brain cells as the mouse processed visual information. Then the researchers cut out a small piece of the brain and sliced it into more than 25,000 ultra-thin pieces. Next, they used electron microscopy to take more than 150 million high-resolution images of those pieces. Previous wiring diagrams, as the images are known, have mapped connectomies for the fruit fly and human brains. One reason the researchers' study has been so well received is that the data set has the potential to improve scientists' understanding of the brain and possibly help them treat brain disorders. Venkatesh Murthy, a professor of molecular and cellular biology at Harvard University who studies neural activity in mice but was not involved in the study, says the project gives him and other scientists a bird's-eye view into how single neurons interact, offering an exquisitely high-resolution freeze-frame image that they can zoom into. R. Clay Reed, a senior investigator at the Allen Institute, says that before the program's research was complete, he would have thought this level of reconstruction was impossible. Reed says that with machine learning, the process of turning 2-dimensional wiring diagrams of the brain into 3-dimensional models has gotten exponentially better. It's a funny combination of a very old field and a new approach to it, he says. Reed compared the new images to the first maps of the human genome, in that they provide foundational knowledge for others to use. He envisions them helping others to see structures and relationships inside the brain that were previously invisible. In many ways, this is considered as only the beginning. These data and AI-powered reconstructions can be used by anyone with an internet connection and a computer to ask an extraordinary range of questions about the brain. Finally, I'd like to recall the words of sensational American poet Diane Ackerman. Imagine the brain, that shiny mound of being, that mouse-gray parliament of cells, that dream factory, that petty tyrant inside a ball of bone, that huddle of neurons calling all the plays, that little everywhere, that fickle pleasure dome, that wrinkled wardrobe of cells stuffed into the skull like too many clothes into a gym bag. Thank you for watching.